Hi guys, here is our day 2 of solving inequalities. Okay, yesterday we focused on how to write them, how to graph them, and we also started with one-step inequalities. Okay, today we're going to actually go into solving a variety of different multi-step inequalities, whether they're two-step, multi-step, variables on both sides, so all different sorts of examples. Okay. So let's just recap how to solve them. So we're going to solve the same way we would solve an equation, okay? But you just treat your inequality symbol the same as an equal sign. And always remember to get the variable by itself is our goal. And then our second step we're going to be doing is we're going to graph the inequality on a number line. And just to recap on our special case from yesterday, when you multiply or divide by a negative number, the inequality sign will flip. Okay, for example, if the sign was less than, then it's going to change to greater than. And I know I spoke about this yesterday in the video, but I just wanted to recap on this as well again. Let's say I had, hold on, my ink is not working. Okay, let's say I had negative 3x is greater than 18. Okay, and when I divide negative 3 to both sides, this is an example of the special case because the number that's attached with the variable is negative. So in this case, I'm going to flip the inequality and it's going to be x is less than negative 6. Now I'm going to compare that to if I had 3x is greater than negative 18. One common mistake that I find each year is that when students go to do this, they say, oh, well, here, look it, this is a negative number. So let me flip my sign. It's not that situation, okay? Because this 3 attached to the x is positive, then there is no flipping of the sign, okay? So then this would just be negative 6. Okay, so I just wanted to kind of point that out. And what you're going to see today, it's going to be later on into the examples. We're going to see two other types of solutions that we've seen already just when we were working with systems. We've also seen it with equations before. We have no solution and infinitely many solutions. And when it's a no solution, you're going to notice when the variables cancel out and the numbers left do not make a true statement. Okay, which that's like a common theme. Every time we're seeing things with no solution, even with systems, when the variables canceled out and it was not a true statement, then it was no solution. Whereas on the flip side, if it's infinitely many solutions, the variables are going to cancel out and the numbers left do make a true statement. Okay, so just kind of keep that in the back of your mind. Okay, so let's get this show on the road. First off, we're just starting with a nice, simple two-step inequality. I'm going to subtract 6 to both sides. Now I'm going to have 3m is greater than or equal to, and then you're going to do 3 minus 6, okay? And then 3 minus 6 is negative 3. Then I divide by 3 to both sides. M is greater than or equal to negative 1. So that's actually just goes back to this statement before that I said when you divide, if this number is negative, you don't flip the sign. Okay, so we're good. No flipping of the sign because this 3 is positive. So I'm going to have a negative 1, 0, 1, negative 2, negative 3. If m is greater than or equal to is a closed circle on negative 1, shading to the right to all the greater numbers. Okay, example 2. Example 2, got a little distributive property going on here. I'm going to distribute the 4 to both terms inside the parentheses, and I'm left with 4b minus 16 is less than or equal to 36. Now I'm going to add 16 to both sides. Now I'm left with 4b is less than or equal. 6 plus 6 is 12. 3, 4, 5. Now I'm going to divide by 4. And 4 goes into 52 13 times. Okay. So again, there was no negative coefficients in front of those b's, no sign changing, nothing like that. So I'm going to set up my number line. It's going to be 13, 14, 15, and then 12 and 11. It's less than or equal to. Less than or equal to is always a closed circle on 13. And again, it's less than, so I'm going to shade my numbers that are less than. Okay. And I include the arrow too because, again, not just 12 and 11 are solutions. It goes on and on and on. Okay. Example 3. My first step is to undo the addition or subtraction. So I'm going to subtract 2. Now I'm left with negative 1/3 x less than 3. Now in order to get the x by itself, I'm going to multiply by the reciprocal. And now, if you notice, I multiplied by a negative number that was attached with the variable. So that means I'm going to flip the inequality. And now 3 times negative 3 is negative 9. Okay. Negative 9. -8. X is greater than, an open circle, shading to the right. Good. Okay, now example 4, we have 4 is greater than or equal to n over 3 plus 5. Okay. First step, I'm going to subtract 5. 4 minus 5 is negative 1. Okay. Now I have n over 3, so I'm going to multiply both sides by 3, or 3 over 1, whatever works best for you. And 3 times negative 1 is negative 3. Now, anytime you find, and we talked about this yesterday, if your variable is on the right side, again, I would advise you to solve normally. Don't try to turn the whole thing at the beginning because honestly, I find too many errors that happen there. So I would solve just like you would a regular equation. And then when you're finished, then take that following step and reverse the entire thing. And when you're reversing, so I'm going to put my n first. I'm going to look and see what's going on next to the n. If you notice, next to the n is the point. Okay, so when I reverse the entire thing, I'm going to put the point towards the n. Okay, and then I'm just going to put negative 3. Okay, it's very important you do this before you graph. Okay, because again, most of the time, if we don't do this, we end up shading the wrong way and things like that. So just make sure you, rotate the entire inequality before you graph. Okay, so we have -3, -2, -1, -4, -5. Okay, so I'm going to do a closed circle on -3 and shading to the left. Good. Okay, example number 5. Little multi-step action going on here. Hopefully you're looking at the left-hand side and you're saying, ooh, 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 I want to combine, I want to combine. So when I like to combine terms, I like to circle them, the ones that are like, or box them, put a cloud around them, whatever. Okay, so I can combine 4x plus -6x, which is going to give me -2x plus 5 is less than or equal to 13. Now I'm going to subtract 5. Okay, so now I'm just left with the two-step equation. Now I have -2x is less than or equal to 8. 13 minus 5 is 8. Now I'm going to divide by -2. Ding, ding, ding. Special alert here. My coefficient by the x is negative. Okay, so I'm going to now flip the inequality sign. And 8 divided by -2 is -4. Okay. Okay. So x is greater than -4. So I'm going to do a closed circle on -4, shading to the right. Okay. If you recall back when we did inequalities, this is a special case one. Okay, first I want to get rid of this 2 down low. So I'm going to multiply both sides by 2. Now I'm left with 4k minus 8 is greater than 20. Now I'm going to add 8. And now I'm left with 4k is greater than 28. Divide by 4, divide by 4. K is greater than 7. That was a nice one. No negatives involved. Just good old positive numbers. 7, 8, 9, 6, and 5. K is greater than 7, so just greater than and less than, get the open circles. And there we go. Okay. Good. Almost there. Okay, now we have a little bit of variables on both sides. So what I'm going to do is I want to move one of the variables. It does not matter. I like to always say I like to move the smaller one. So I'm going to move the 3x to the other side. 3x minus 3x cancels out. 5x minus 3x is 2x minus 12 is less than or equal to, and don't forget this is -4 when I bring it down. Okay. Now I'm going to add 12. Now I'm going to do 2x is less than or equal to -4 plus 12 is 8. Now I divide by 2, divide by 2. X is less than or equal to 4. So 4, 5, 6, 4, 3, 2. X is less than or equal to 4. I'm going to put a closed circle on 4, shading to the left. Good. Okay. So again, this left side could use a little cleaning up. 10h plus negative 3h is going to give me 7h. Plus 6 is greater than or equal to 11 plus 7h. I'm going to move this 7h. You might start to notice something right now because both of them are positive 7/8, 7h's. Okay, so that's going to cancel both of them out, and it's going to leave me with 6 is greater than or equal to 11. And you have to say to yourself, is 6 greater than or equal to 11? No, it's not. So then that would mean it is no solution. Now, when it comes to graphing, if there's no solution, well, then there's going to be no graph, okay? Because what am I going to shade in? Nothing. There's no solution. There's not one number that would work in this situation. So you would just keep it like that. Next, we're going to do our last example. I have distributive property on both sides. So I'm going to come out with 6t minus 6 is less than or equal to 6t plus 10. Now I'm going to subtract 6t to both sides. Negative 6 is less than or equal to 10, which is a true statement. So then that would mean infinitely many solutions. Now, infinitely many solutions mean that any single number on a number line, so there's an infinite amount of solutions. So what I would do there is I would just highlight and do both arrows, okay, because that shows that any number is a solution. Okay. So now I have 6 problems that you can try. So at this point, I would say, hey, stop the video, pause it, work on these, okay, and see how you do. Okay. Okay, so I'm going to go over these answers, okay. I'm going to go, a little quicker than normal just to kind of show you these. Minus 9, minus 9. 24 minus 9 is 15. It's greater than or equal to negative 5m. Divide by negative 5. Divide by negative 5. Here's this special scenario when you're dividing by a negative. What that means, I'm going to flip the inequality. Do not flip around your variable yet. 15 divided by negative 5 would be negative 3. Now I would say reverse the entire thing and put your m first. Remember to look here, see how the opening is to the m. So I'm going to put the opening to the m and negative 3. Okay, let's go to the next one across. 14x plus 5 is less than 14x minus 21. If you subtract 14x to both sides, You're going to notice that they cancel out, leaving you 5 is less than negative 21. So when you have the variables cancel out and you're left with a true statement, then you find it's infinitely many solutions. If the variables cancel out and you're left with not a true statement, then it's no solution. So you have to think, is 5 less than negative 21? And nope. So it's no solution. Okay, next one, 6 times 1/3. We'll always think whenever you take 1/3 of a number, it's just like dividing by 3. So 6 divided by 3 is 2d plus 24 is greater than 2d plus 24. If you notice, your variables will cancel out, leaving you 24 is greater than 24. This again would be a no solution. Okay. Now, on the reverse side, if it was 24 is greater than or equal to 24, then it would be infinitely many solutions because it could have been equal to. Okay, the fourth example, or the fourth practice problem, I'm going to subtract 3x. I'm left with 2x minus 12 is less than or equal to negative 4. I'm going to add 12. Now I'm left with 2x is less than or equal to 8. X is less than or equal to 4. Okay. Down low, I'm going to subtract 4. With m over negative 5 is less than or equal to negative 2 plus negative 4 would give you negative 6. Now in order to get m by itself, I'm going to multiply both sides by negative 5. Here's the special scenario again, because you're dividing by you're multiplying both sides by a negative. So I'm going to reverse and flip the inequality sign, and negative 6 times negative 5 is 30. And last problem. Add 5n. Now I'm left with negative 4 is greater than 12n plus 20. Subtract 20. We have negative 4 and negative 20 is negative 24 is greater than 12n. Divide by 12. Divide by 12. N less than negative 2. And then again, you want to reverse that. The point is going to the n, so I would put the point to the n. And there we go. Okay, good job. Hopefully you followed along with all these examples today. Let's move on to the Now What screen. I've set up a Kahoot for you to play, or really just, work on individually. The pin is 033333858. You'll find that the link is posted to the Google Classroom, and we are giving you 2 tries to complete this. Okay, and we will be taking your percentage. If you complete it, you'll get your 20 points for the day. Also, whatever percentage you get will also be a math application grade. And then don't forget to complete the daily check-in form. Okay. And if you're listening to this earlier in the day, then we are having a Google Meet at 12:15. Hope to see you there. Okay, and don't forget to ask any questions if you need any help. Okay, bye guys. Have fun.